Welcome everybody. We are going to try the video lesson one more time. You should have the July 30th packet out, and we are going to begin with the first topic, which is celestial objects. Celestial just means in space. An object is just a thing that exists. So celestial objects are just everything in outer space. What could those be? They could be stars, planets, comets, and asteroids. We'll add meteors to the last thing. So we have stars, planets, comets, asteroids, and meteors. And when we talk about these different objects of the solar system, we're going to classify them in terms of scale. So the smallest scale, we have the things right around us. So that's around our sun. So it's the solar system. And then beyond that, we have our galaxy. And then bigger than our galaxy is everything in the universe. And these are just classifications based on size. And it turns out nothing in space is actually going to be stationary. Try to picture an object on a icy floor. It's not going to come to a stop easily. And in space, there's nothing to make anything stop. So it's bound to happen that it's going to start moving at some point. And once it starts moving, it's never going to stop. The first two ways that this happens are both very much related. So objects are going to revolve in an orbit around other heavier objects because of gravity. So that's why the moon is going to orbit us and why we are going to orbit the sun. And all of these orbits are going to happen in ellipses. So they're not perfect circles, they're kind of ovals. Ellipse is just another word, or elliptical is another way of describing a kind of circular but not quite orbit. And completely unrelated to that motion around an object, objects are also going to kind of spin like a top on a table. So we call this spinning motion. Another word for that is rotation. That's kind of the fancy word, so you'll see that in a lot of places. It's just a fancy word for something spinning, and it's spinning on its axis. That's just the central point of the object that everything else is moving around. The axis isn't a real thing, it's just an imaginary idea to describe that rotating motion. Now, why does the Earth orbit the sun and why does the moon orbit the Earth? Well, it all comes down to gravity. Gravity is just the force that pulls objects together. So the Earth is pulled towards the sun, and that and a combination of its movement, it kind of balances out and it never gets any closer, it just orbits the sun. Think about when you're kind of imagine an object on a string, and you're swinging it around in a circle. You have to pull on that string to keep it going in a circle. So it's like the sun pulling on the Earth. So it's moving around in a circle and never gets any closer towards you, and it's moving in that circle because of a pull towards the center. That's exactly how gravity works. All right, so coming back to our solar system, there are kind of two models that you got to be able to talk about when it comes to this. So the first is what people back to Aristotle, the way that they thought the universe worked. They thought that things that up were in the sky, they were all perfect. Because they were perfect, they moved in perfect circular shapes. And the Earth, which was imperfect, didn't move, and it was at the center. They didn't see any evidence that the Earth moved. They couldn't find any evidence that the Earth moved, so they didn't think it did. Geo is just a prefix for the Earth. Geology is the study of the Earth. Geologic history is Earth's history. So the model of the universe where the Earth is at the center is going to be called geocentric. And it's going to look something like this. With the Earth at the center here, the Earth right there, and then all of the planets on the outside. You'll notice that there's these little circles on the outside of the planets, and those are because in order to account for all of the motion that they saw, it looked like Venus was going backwards at certain times. So they explained this as Venus was kind of like on another circle inside of its larger circle. So this was to explain something called retrograde motions. These circles within circles. The guy who first came up with these circles with the most advanced geocentric system was this guy. And you can pronounce that Ptolemy if you ever are trying to. So you don't pronounce the T or the P at the beginning there. And it looks a little bit weird. It's sort of hard to understand, and it was rejected in large ways because of the complexity of the model, but we should note that it was actually very accurate. We no longer believe this model to be true. Instead, we believe that the sun is actually at the center of the solar system, and planets follow elliptical paths around it. The first people to pioneer this idea were Copernicus, Kepler, and Galileo. So again, we call this a heliocentric model, and it puts the sun at the center. Helio is another word for the sun. And this is the model that you're likely to be more familiar with. You'll notice that it puts the sun at the center here, and all of the planets, including Jupiter and Venus and us, we all orbit around the sun. Our moon independently orbits us. The planets all orbit the sun, which is at the very center, which is why it is a heliocentric model. Now, we believe this in part because we have evidence that the Earth rotates on its own, that things aren't just orbiting around it. The evidence for this is something called the Foucault pendulum. This was actually a question on your June Regents exam. You got credit if you just wrote pendulums. You don't need to worry too much about the guy Foucault, but it's technically a Foucault pendulum. And the way it works, there's a fixed point at the top, and this bob is just going to swing back and forth. Now, because Earth is going to be rotating underneath it, so this platform is going to be rotating underneath that fixed bob, it's going to appear to us, because we're going to be standing on the platform down here, somewhere there, and we're going to be moving on that platform, it's going to look like that ball is swinging on a slightly different path. And this has been repeated. They had one at the Science Center at Geneseo in the lobby, and it is proof of the heliocentric model.